Question number 4. At the beginning of each year for 10 years, $100 is deposited into a savings account. At a simple annual interest rate of I, the total amount in the account is $1,275 at the end of 10 years. To the nearest $5, what would be the total amount in the account at the end of 10 years if interest had been compounded at an effective annual interest rate of I%? So let's start this off by writing down the first equation that the question gives us. That is $100 for every year for 10 years will accumulate to a total of $1,275. Well, for the first year, we have 1 plus I. We'll divide this by 100 just because whatever answer we finally get for y will just be a percentage at the end. Plus 1 plus 2i divided by 100, etc. And here we have 1 plus 10i divided by 100. Now, just to simplify this, we get 100 times 10 plus a total of 55i divided by 100, which equals to $1,275 at the end. So, because there's only one I here, this is the amount in year 9 that gets brought forward 1 year. Because there's 2i here, this is essentially the amount in year 8 that gets brought forward 2 years. Here, this is the amount in year 1 that gets brought forward for a total of 10 years. Simply figuring out what I is, we have 275 divided by 55, which equals 5. And because we were dividing by 100 here, this 5 is a percent. Now, at a compound interest effective rate of 5%, the accumulated value, which is our AV, will equal 100 S double dot angle 10, because we're looking at 10 years, at an interest rate of 5%. Plugging these numbers into your equation, you end up with a total of $1,320.68. Rounded off to the nearest $5, it's simply $1,320. And just as a quick double check, we do know that this answer is likely correct simply because it is greater than your accumulated value using a simple interest rate, right? Because using a compound interest rate, interest builds on the interest payments you get every single year. Therefore, this should be greater.